Hello sir, I'm doing assessment 4 and I'm solving problem 38 from chapter 4, and the problem is as us to calculate the Young's module of the wire, and to solve that, here are the given data. The given data is like a ball is hanging on a gold wire, and where the mass of the ball is 14 kilograms, the length of the wire is 2.5 meters, and the diameter of the wire is 2 millimeters. I changed it to meters so it's easier to work with, so which is 2 times 10 to the negative third meters. Then I found the cross-sectional area of the wire, which we need to solve the problem. So the formula for that is A is equal to pi d over 2 square, where d is the diameter of the wire, which we found here. I plugged it in and I got a value 3.14 times 10 to the negative 6th meter square. And the stretch in the wire, the change in length, which is given, which is 0.001339 meters, and the gravity is 9.8 meters per second square, and the tension in the wire, which is Ft, is mass times gravity, so which is 14 times 9.8, which gives us a value of 137.2 newtons. With this information, we can calculate the Young's module. Young's module is nothing but stress divided by strain, where stress is a tension of a material over the cross-sectional area, and strain is nothing but the change in length over the original length. We found all that values by plugging it in. We have a value of 7.86 times 10 to the 10th newtons over meters square. And the second part of the question is to calculate the interatomic spring stiffness of gold. So the given are the atomic mass of the gold, which is 197 grams per mole, and number of atoms in a mole, which is nothing but Avogadro's number, which is 6.02 times 10 to the 23rd atoms, and mass of each atom, which we need to solve the problem. So which is nothing but the atomic mass of the gold divided by the Avogadro's number, which gives us a value of 32.72 times 10 to the negative 23rd grams per mole, grams over atom. And the density of the gold, which is given, which is 19.3 grams per mole. Then with this information, we need to find the number of atom in cubic centimeter. To calculate that, we use this formula: N is equal to density over mass per atom. Density is 19.3, and mass per atom, which we found here, which is 32.72 times 10 to the negative 23rd. By solving that, we get a value of 5.9 times 10 to the 22nd. After that, since it's arranged cubically, we need to find out how many atoms are in the side of a cube. To calculate that, we use the small n is equal to the cube root of n, then which we just found. So we take the cube root of 5.9 times 10 to the 22nd, which gives us a value of 3.89 times 10 to the 7 atoms over centimeter. After that, so if n atoms are in length of 1 centimeter, we can find the interatomic distance. To find that, we use this formula: d is equal to 1 over small n, which we just found. By dividing it and changing it to meters, I have a value of 2.57 times 10 to the negative 10th meter. With all this information, we can finally calculate the interatomic spring stiffness for gold, which we use the formula KSI is equal to Y and D. Y we found here the Young's module, which is here, and D the interatomic distance we found here. By multiplying it, we get a value of 20.20 newtons over meter. Thank you.